Mineral exploration is a thrilling quest to uncover the raw materials that fuel our modern world. From the metals in your smartphone to the components of your car or even your toothbrush, minerals are the unsung heroes behind everyday objects. This guide takes you deep into the world of mineral exploration, the special focus on Mississippi Valley-type lead-zinc deposits, which are critical sources of lead and zinc, metals essential for batteries, construction, and more. Imagine discovering a deposit with over 8% zinc, featuring our beds thicker than 3 meters and packing more than 15% zinc. That's the dream of every prospector. MVT deposits are unique geological formations where metal-rich fluids have percolated through carbonate rocks, such as limestones and dolostones, depositing lead and zinc minerals. These deposits often lie hidden deep beneath the Earth's surface, but they leave subtle clues for observant geologists. Faults fractures in the Earth's crust, tan structural highs like fold domes are prime locations where these fluids may have been trapped, forming rich ore bodies. Spotting these clues requires a detective's eye. Limestones, common hosts for MVT deposits, are typically light to dark gray and fizz vigorously when tested with weak acid. Dolostones, by contrast, are often tan to brown with a sugary texture and react weakly to acid, unless powdered. Galena is striking. Freshly broken, it gleams silvery and cubic, while weathered surfaces turn dull blue-gray, standing out against the host rock. Its surprising heft is a telltale sign. Picking up a Galena-rich rock feels like lifting a lead weight. Its colors range from honey brown, blending into dolostones, to yellow, red, or black. The science and art of mineral exploration. Mineral exploration is a scientific pursuit that demands keen observation, deep geological knowledge, persistence, and creative thinking. It's driven by the economic promise of mining, which creates jobs, infrastructure, and the materials for modern technology. Historically, prospectors relied on surface signs. But today's tools, aeromagnetic surveys, satellite imagery, and air photos allow exploration of vast regions, revealing subtle anomalies missed by earlier efforts. Contrary to the belief that all easy deposits have been found, skilled explorers continue to discover new resources in well-explored areas by noticing overlooked clues. Exploration unfolds in stages. Target generation. Sift through data to pinpoint prospective zones. Most prospects fail to reach the final stage, but those that do are exceptional. Success hinges on generating high-quality targets and testing them efficiently. Exploration strategies blend empirical approaches, which cast a wide net, with systematic surveys and conceptual ones, driven by geological models. Empirical methods yield many anomalies, most of which are quickly ruled out, while conceptual approaches produce fewer but higher quality targets. Most programs combine both, balancing theory with real-world data. New tools, models, or funding can transform a dead end into a breakthrough. Finding a deposit requires identifying the one reason an area might host, or not the many reasons it might not. Collaboration is vital. Exploration companies engage with local communities, indigenous groups, and governments to ensure projects are economically, socially, and environmentally responsible. Exploration is also costly, often requiring millions in funding, typically raised through share sales before any mining revenue is generated. Geological mapping is the cornerstone of exploration, creating visual representations of geological observations to predict or locations. Maps are more than data, they're human artifacts reflecting a geologist's expertise and interpretations. Intelligent mapping starts with hypotheses about the geology, followed by fieldwork to test predictions. Case and compass. Quick, but less accurate, suitable for rough sketches. Tape and compass. More precise, ideal for linear features like trenches. Pegged grid. Accurate for established prospects, but costly to establish. Plane table. Highly accurate for small, complex areas, but slow and labor-intensive. GPS. Fast and digital. Great for regional mapping, but less reliable in dense forests or near cliffs. Remote sensed imagery. Air photos and satellite images provide overhead views, revealing large structures. Satellite images offer global coverage and can be orthorectified for accuracy, while stereoscopic air photos provide 3D insights. Interpretations are marked on overlays to preserve flexibility. Trenching and underground exploration. When surface clues are buried, prospectors dig trenches or pits using bulldozers, excavators, or even hand tools. Ground adits horizontal tunnels offer direct access to deeper deposits but are expensive, used only when drilling is impractical. Trench mapping involves marking walls with spray paint and collecting chip channel. Samples continuous lines of rock chips for geochemical analysis. Samples are cut with jackhammers or diamond saws and split to manageable sizes using canvas sheets or polypipes, ensuring representative data without excessive weight. Drilling. Testing the Earth's secrets. Drilling is the ultimate test of exploration hypotheses, confirming or challenging models of, or bodies. Auger. Drilling. Inexpensive. Used for shallow soil sampling and unconsolidated material. Hand augers suit remote areas, while power augers dig deeper. Rotary percussion drilling. RAB is fast and lightweight for shallow geochemical sampling, while RC drills deeper with less contamination, ideal for gold and weathered zones. Diamond drilling. The most expensive but highest quality method, producing solid rock cores for detailed geological analysis. Oriented cores reveal 3D structures. The choice of method depends on project goals and budget. Geologists log every meter of core or cuttings, noting mineral changes that may signal an ore body. Logging methods include prose descriptions, graphical scale logs, or analytical spreadsheets with standardized codes. Geophysical and geochemical exploration. When bedrock is hidden, geophysical and geochemical methods extend the search. Geophysical surveys measure rock properties. Magnetic surveys detect magnetic field changes to map hidden structures. Gravity surveys identify dense sulphide bodies. Electromagnetic surveys find conductive sulphides, though water-filled faults can mislead. Induced polarization detects disseminated sulphides via electrochemical effects. Geochemical surveys analyze metal traces in stream sediments, soils, or rock chips. Stream sediment sampling identifies metals washed downstream, while grid-based soil sampling pinpoints buried deposits. Heavy mineral concentrate sampling, like panning, reveals dense minerals in the field. Rock chip sampling uses jackhammers to collect outcrop pieces for assay. Defining anomalous values requires human judgment to avoid over-relying on computer thresholds, as software may produce misleading patterns. The digital revolution. GIS and databases. Modern exploration generates vast data, managed through geographical information systems and digital databases. Databases store drill logs, assays, and surveys, enabling 3D or body models. Mineral exploration is a dynamic blend of traditional prospecting and advanced technology. Chasing hidden treasures like MVT lead zinc deposits. From mapping and drilling to geophysical surveys and digital modeling, it's a cycle of observation, hypothesis, and testing. This challenging field secures the raw materials that power our world, balancing economic goals with social and environmental responsibility. Whether you're a geologist or an enthusiast, the pursuit of Earth's riches is a journey worth taking.
Welcome to the world of geology and earth sciences with Ricardo Valls, a seasoned professional geologist bringing you over 650 videos of unparalleled expertise. Whether you're a budding graduate student, an early career specialist, or a seasoned professional, this channel is your gateway to a wealth of knowledge. Explore a vast array of Earth-related subjects, including geology, geochemistry, structural geology, and the application of artificial intelligence and machine learning in geosciences. Ricardo Valls not only shares his own invaluable insights but also brings you exclusive interviews and collaborations with other prominent geologists, offering a comprehensive view of the field. Stay ahead of the curve with our latest content, covering everything from unraveling the Earth's secrets to exploring global geological phenomena. Don't miss this opportunity to enhance your knowledge and stay at the forefront of the industry. Subscribe now, hit that like button, and share this invaluable resource with your colleagues and friends. Join our growing community of over 1,800 earth science enthusiasts and professionals today. Unlock the secrets of the Earth with Ricardo Valls, your top resource for all things geology. The future of geosciences is here. Be part of it.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell